Hello friends, so today we are solving this problem longest binary subsequence less than or equal to k. So we are given a binary string s and a positive integer k. So return the length of the longest subsequence of s that makes up a binary number less than or equal to k. So we can visualize like this. For example, this is our string and this is the k value is 5, which is also can be represented as in this way in the binary terms. So what we have to do is there could be multiple subsequence. So in subsequence, we can skip certain values, but we have to keep the their order should be still same. Okay, so there could be multiple subsequence which are lesser than or equal to this k, right? In this case 5. So for example, let's say if we pick 0, 0, 1, and again a 0, again a 0, this also a valid one. We can have like 0, 0, and another 0, another 0, another 0, 1 and 0. This also could be a binary number, one subsequence which is lesser than or equal to k. Similarly, we can have such that there could be multiple such which we can have, right? So we are skipping certain ones or zeros, but their positions in the answer should be still, basically the ordering should be still preserved. Okay, so there could be multiple such values, but we have to find the longest one, basically the length of that longest one. So how to do that? That is the criteria. So one assumption we want to go ahead here is as much as possible we want the zeros, because leading zeros are not creating the problem, and it would be adding the length to up to maximum. So our one assumption is, first of all, we want to keep all the zeros. Then we have to pick that how we can pick the ones into it. So let's say there are 6 zeros in this case, right? So let's say I want to pick all of them initially. Okay, so I will pick this 0, I want to pick this as well, I want to pick this as well, this as well, all of them. My intention is greedily I want all of them as much as possible. Now we have the places, right? Between these zeros we have to fill our ones. Okay, that so we have to look for those positions that where all we can put those ones. Okay, so how do we do that? Let's say we are going from right to left. Okay, why right to left? Because we want to keep the who all ones can be included. We have to compare with this k, right? So that we can keep on them. So let's start with this. Suppose we have a variable called power. Okay, why this power? Power is like it would be a place value, like this would be 1, this would be 2, this would be 4, like that, right? So we want to keep this power variable. So initially it has like POV equal to 1. Okay, now we are coming to this place, right? We are traversing into this. So this is already 0, which we have already picked, so not a problem. Now our power is 1. At this location power was 1, and next time when we are coming to this location, power would become what? So power would become left shift. Okay, left shift 1 time. So power would be equal to power and left shift 1 time. Power left shift 1. So what does it mean is left shift is nothing, it makes the 2's power, right? If it is power equal to 1, so we can write it like this: 1 is equal to 0, 0, 1. Now if we do 1 left shift, what it would be happening? 1 place it would be increased, right? 1 will come here and this will come here. So initially this was 1, now this would become 2. If I do 1 more left shift, it would become like this 4, right? So this is like 2's power, right? This is 1, this is 2, then this is 4, next would be 8. So that is why we are doing this left shift operator. So when we reach at this location, our power would become this, right? Power would become 2. Okay, so far our value, current value, let's say we have a car value variable. Okay, car val. Okay, so car val initially was 0. Now when we were here, it is 0. So we are skipping the zeros. When we reach this 1, so at this one, what would we have? Our car val would become whatever is the car val value plus power. Okay, so at this location our power become 2, right? So till here we have got 2, and 2 is lesser than 5, 2 is lesser than k, so we are valid, we can still traverse. So we will keep on counting these ones, right? So we can consider that 1 can be put here, right? This 1 is valid because still it is car value is equal to 2 only. Now we will come to this location, right? So at this location, what would be the car val? Car val equal to 4. power, yeah. So power would be here 4, right? Then we are coming to this location. What would be the power? Power would become 1 0 0 0. This would become 8. So we have to stop at this place, because doesn't matter how many ones are there on left side, we cannot pick them, right? Because till here itself it become 8, right? Which is greater than 5, the value of power. So we have to stop at this place itself. So this could be our longest one. Now you can observe that we are accommodating all the zeros, and then we found that what all ones we can pick, right? So this would be our greatest one. So we are picking all the zeros, then we are looking that up to what location a 1 can be included. Now you can consider here, because we are counting in the question it is given that give the maximum length only, not the exact subsequence. So you can do one thing. Till the time we are getting the valid ones, we can have a variable called count1. Okay, we can have a count1 c1. So c1 initially it is 0. So when we came here, it at the first one it became 1, right? And we can have also one function called count zeros, right? Because we are interested only in the total length. So we can write a method which will count all the zeros, right? Starting from very first till end, we will keep on keep on. So 6 would be this total 0, and 1 is the valid one that we found. So what would be the final answer? Would be count of ones plus count of valid ones, count of valid ones and count of valid zeros. So 6 plus 1. Okay, so 7 would be answer. You can check here. 2 plus 2 4, 4 to 5, and 6 7, right? So 7 is the answer. So this is how we are gonna do it. Let me show you my corresponding code for it. So see here, this is my code. So first of all, I have just written a method which will be count all the zeros. Okay, so we are starting from here. This is my length of this string. Then I'm counting the all zeros in the string, because we want to grasp all as much as possible all the zeros. Now see here, I'm starting this power equal to 1, right? When we were starting from right to left, at the very first 0, our power was starting with 1, right? 2 to the power 1, right? So in this way, and this curve value is initially 0, and valid one would be having the all the valid ones count. Okay, now see here, I'm traversing from right to left, because we want to look for the significant ones to include it. So whenever we are getting a value equal to 1, then we have to check that if curve val plus power is greater than k, that means we have to continue, because adding this would not add any value for us, because it is going beyond k. Now when it is 1, we are increasing the count of valid ones, and current value equal to current value plus power, right? Just like this, we were keep on going. Initially it has 1, then it came at this first green, then power curve value become 2, right? Then at this location curve value become 4, at this location it is become 8, so we broke it, right? So same way we are doing here. So when we are coming at here, every time this power would be left shift by 1, basically 2 to the power whatever is the next power, we are going in that way. So whenever a power is going greater than k, then there is no point of checking any one, right? There's no point of checking ones, because we cannot add. For example, till here, till the first green one, we were fine, because power was 2 only. Then we came here, at the next one is 0, power was 4, then power suddenly become 8. Then there is no point of checking further one, right? So we have got it in that way. So finally what we are doing, when we will come out of this loop, we are returning the count of all the zeros plus all the valid ones. So let me execute this code. So yes, and let me try to submit it. So we are not taking any extra space, only in 2 pass we are able to solve the problem, and it is 100% faster. Okay, now you guys can try one thing here. I am taking first the count of zeros, and then I am taking the valid ones. Try this with single for loop only. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.